Webb telescope finds a star cloaked in 3 rings of ruined worlds. Astronomers have gained a new understanding of the chaos that wreathes the bright star Fomalhaut with the help of the powerful space observatory. Fomalhaut, a star just 25 light-years away, is so dazzlingly bright that it blots out the faint light of other stars around it. Stargazers have been enraptured by its secrets for thousands of years. Now, with the help of the James Webb Space Telescope, astronomers have documented evidence that Fomalhaut is a dynamic star wreathed in cosmic chaos. The powerful observatory's infrared vision is letting astronomers better understand Fomalhaut's features, including a mysterious ring unlike anything found in our solar system. It's complex, there's so much going on, said Andres Gasper, an astronomer at the University of Arizona and one of the authors of a study using the Webb observations that was published Monday in Nature Astronomy. It's the first time we've seen such structures in an evolved system. The findings could contribute to the solution to an existential puzzle. How weird or ordinary is our solar system? It's hard to draw conclusions about if we are common or not, if our specific configuration is everywhere or nowhere, said Jesse Christensen, the project scientist at NASA's Exoplanet Archive, who was not involved with the new study. Fomalhaut dwells in the southern constellation Piscis Austrinus. The star is 440 million years old, young compared with our 4.6 billion year old Sun. But Fomalhaut is a type of star that lives no more than 1 billion years. That means that, much like the Sun, it is halfway through its expected stellar life. Fortunately for the living things in our solar system, the Sun shows no signs of a midlife crisis. Aside from the occasional asteroid or comet impact, most larger objects stick to their orbital lanes. Much of the cloud of debris that cloaks younger stars congealed eons ago into the 8 discrete planets, with the main remaining fields of cosmic wreckage being the rocky asteroid belt between Mars and Jupiter and the icy Kuiper belt beyond Neptune. Fomalhaut offers a more reckless take on Middle Age and a contrast with our orderly planetary system. But it was only recently that technology caught up with astronomical ambitions to understand the star's scattered surroundings. For the new study, Dr. Gasper and his team pointed Webb's mid-infrared instrument at Fomalhaut. Unlike earlier space and ground telescopes, Webb can detect the faintest infrared glows emitted by dusty debris, and it revealed not 1, but 3 nested rings of ruin around Fomalhaut. The inner ring is analogous to our asteroid belt, while the outer ring is comparable to the Sun's Kuiper belt. But Fomalhaut also has an intermediate debris highway between the two, most likely a mix of icy and rocky ephemera. The solar system lacks this superstructure, in part because we've got these big honking planets in the middle, Jupiter, Saturn, Uranus and Neptune, that cleared stuff out, said Bruce McIntosh, the director of the University of California Observatories, who was not involved with the study. The gap between Fomalhaut's inner and intermediate rings may have been carved out by a planet, but no direct evidence of any worlds could be seen. By this point in Fomalhaut's life cycle, most planets would have cooled off, and only one many times the size of Jupiter would still be hot enough to be detected by the Webb's infrared instrument. You could hide Jupiters in there, all over the place, and nobody would know, Dr. McIntosh said. The intermediate belt is also where exoplanet hunters once thought they had seen a world they named Fomalhaut B, but in 2020, Dr. Gasper and his colleagues proposed that what other scientists had once thought was an intact exoplanet was actually an expanding cloud of debris created by an epic collision. A problem with this idea was that this part of space looked vacant, so it seemed unlikely that 2 objects had managed to crash into each other. The team's discovery of the intermediate debris belt has now proffered a solution. We now know there's stuff there, Dr. Christensen of the NASA archive said. Okay, so it's a collision, we can finally put that to bed. Cataclysmic melees are not just transpiring close to the star. What looks like a vast maelstrom of dust within the outer belt may be the ghost of another gargantuan impact. That's just cool, Dr. Christensen said. What is it? It's very tantalizing. Astronomers are thrilled that the Webb telescope offers a front row seat to this star's drama. It also makes them appreciate the comparatively tranquil nature of the solar system. Fomalhaut would be chaotic as hell, Dr. McIntosh said, adding, if there are planets there, they're getting smacked around by asteroids all the time. African crater adds an asteroid strike to the late dinosaur era. The impact that made the submarine depression probably occurred close to the dinosaur-ending Chicxulub event, but researchers say much remains to be learned. About 66 million years ago, Earth was smacked in the face by an asteroid. No, not that one. Another one. In the journal Science Advances, scientists on Wednesday reported that a huge, buried pit off the coast of Guinea in West Africa had all of the appearances of an impact crater made by a meteor. Its depression is far wider than it is deep, some of its rocks have been violently cracked apart and folded over themselves, and it has a telltale central rocky peak, something usually made by the flow of rock that briefly behaved like melted butter. The exact age of this putative crater, named Nader by the study's authors, is yet to be determined. Based on its apparent position in Earth's geologic layer cake, it may have formed not long before or after Chicxulub, the 100-mile-wide chasm under the Gulf of Mexico excavated by a 6-mile-long asteroid that caused global devastation, which ended the age of the dinosaurs. This scar beneath the waves could have much to teach scientists. It may open a window into a destructive chapter of Earth's past, revealing how the world weathered bombardment from space during a planet-wide ecological regime change. Because of Earth's ability to frequently purge or bury its surface through erosion, eruptions and plate tectonics, impact craters are often difficult to identify. Iwistine Nicholson, a geologist at Heriot-Watt University in Scotland and one of the study's authors, found Nader serendipitously. He was perusing maps of the region made with seismic surveys by the energy industry. That's when I came across this object, and I thought, that's unusual, Dr. Nicholson said. He and his colleagues estimated that the projectile that plunged into the waters off Africa's west coast was a stony asteroid 1,300 feet long, moving at 12 miles per second. Its impact unleashed an explosion equivalent to 5,000 megatons of TNT, 100 times as much energy as the most potent nuclear device ever detonated. Any animals on the shoreline nearby would see another sun, said Veronica Bray, a planetary scientist at the University of Arizona and an author of the study. Anything close enough would be pummeled by a 2,000-mile-per-hour blast of wind, powerful enough to fold a car around a lamppost, Dr. Bray said. A skyscraper-high wall of water would thunder toward the coast at 900 miles per hour. Then the water evicted from the ocean by the impact would cascade back into the still-forming crater, rush into the middle and splash 6,500 feet into the air before collapsing to create another colossal tsunami. In time, the chaos would conclude. Ground Zero, on that submarine plateau, would be commemorated by a 5-mile-wide crater, one ultimately smothered beneath 1,300 feet of sediment. This impact event, drastic though it was no Chicxulub. It was less a destroyer of worlds and more of a regional ruiner. But the epic tsunamis it spawned could potentially affect life on multiple continents, said Bill Botke, a meteor impact expert at the Southwest Research Institute in Boulder, Colorado, who was not involved with the study. The team considered other phenomena, including a hyper-explosive meeting between magma and water, as alternate formation mechanisms. But so far, a meteor impact is the most likely to be the origin story. The geophysical evidence of an impact crater is pretty solid, said David Kring, a planetary geologist at the Lunar and Planetary Institute in Houston, who helped to confirm the Chicxulub dinosaur extinction hypothesis but was not involved in the study. Purported impact craters sometimes turn out to be geologic illusions. The only way to know for sure, including in Nader's case, is to drill into the plateau itself and search for shocked quartz and other signs of impact. Until then, everything else is just speculation built upon speculation, said Ludovic Ferry-Ray, a meteorite and impacts expert at the Natural History Museum in Vienna who wasn't involved with the work. That speculation includes Nader's age, the impact's deleterious effects, and the hypothesis that Nader's meteor is related to Chicxulub's in some way, with both impactors possibly coming from the fragmentation of the same giant space rock. What is certain, though, is that Nader is far from exceptional. Such impacts occur every 50,000 to 100,000 years. Dr. Kring said, meaning as many as a dozen meteors of similar size slammed into Earth in the twilight years of the dinosaur era. Nader was inconsequential to the end Cretaceous extinctions. Dr. Kring said, but such regionally destructive impact events are a fairly common geologic occurrence, scant comfort to those living on Earth today. Comet Shoemaker-Levy 9 was discovered by Carolyn and Gene Shoemaker and David Levy in a photograph taken on Mar. 1993, with the 0.4 meter Schmidt telescope at Mt. Palomar. When Comet Shoemaker